So at the end, these are the questions that you need to solve and submit for this chapter. You have 3 questions here. The first, both of them, these two have operation amplifier. Then what you need to know to do is to apply the steps of solving operation amplifier circuit. That the 2 voltages are the same, the 2 input voltages are the same, and the 2 input currents are 0. So this is how we do it. So for example, here the current, this current equals 0, this current equals 0, this voltage is ground, so this one also is a ground. Then in this case, you know that this Vn equals 0, this Vn equals 0. And then you apply nodal analysis at this input. Okay. So when you apply nodal analysis, you see that this current plus this current plus this current equal 0. There's no problem in these 2 currents because you know them. You know that this one, if this one is Vn or 0, so it is 0 minus Vi over R, then 0 minus V out over R. So these are the 2 first currents. What about the current in the capacitor? The current in the capacitor is C dV by dt. C dV by dt. You have to return back to the current voltage current relation in the capacitor. So this current is C dV by dt, where V is the voltage across the capacitor. The voltage across the capacitor here is Vn. So it will be C dVn by dt. But Vn is 0. Vn is 0. Then you don't have current in the capacitor in this case. Okay, so it will be very easy to solve this problem. But of course, you have to follow the steps. For this one also here, you have the 2 currents equal 0, and you know that this voltage equal this voltage. If this is called V, for example, or VA, whatever, here, then these 2 are exactly the same. Then how do you solve this problem? How do you solve this problem? For this problem, you have to apply a nodal analysis at this node and at this node. And you know that this one here, this is A and this is B. So VA and VB are the same. If you look at A first, so this one is VA minus 0, which is a ground, over R. And this is VA minus V out over R equals 0. Okay, so if you want to write it, okay, so here it is VA over R, because it is minus 0, plus, so this is the first current, plus VA minus V out or VO over R equals 0. Okay, so of course here you can multiply by R to get rid of this R. When you multiply by R, you will cancel this R and the other R. You don't have R. You don't worry about this R. So you will cancel this one, you cancel this one. So it will be VA plus VA minus VO. VA or 2VA minus VO equal 0. Which means that VA equal what? VA equal half VO. 1/2 VO. Okay, so now this is VA. So this VA will be used here as this point. Why? Because this point is the same like A. They are both the same, have the same voltage. So now you need to apply nodal analysis at the other node, which is B. You have 3 currents. This current plus this current plus this current. Okay, the first current is what? Is VB minus this VI divided by R. And the second one is VB, okay, minus VO divided by R. And the third current is C, this C, dVB by dt. This capacitance, C dVB by dt. Remember that what you need to do is to substitute by VB equal half VO. Then in this case, you will have the equation purely in what? In VO and Vn. then you can find the VO, the output, in terms of the input. The third one is very similar to the problems that we solved in this chapter. So what you need to do is just replace this capacitor by open circuit and the inductor by short circuit. Then you short this one, okay, and you open this one, so you don't have this capacitor here. And when you open this capacitor, you have this 5 ohm connected to nothing, so you can remove it. You can remove this one also. Then now you will have this circuit like this. You have this 2 ohm and short circuit and 2 ampere, 3 ampere. So you have this 2 and you have 4. You have 4 ohm resistor. That's it. So now where is the voltage? The voltage across the capacitor is here. This is VC between these two nodes here. So this is VC of the capacitor. Okay. Of course, this is the voltage across the short circuit. You don't have any. You have current. VC equals this current, which is IL. Okay. Time resistance. You don't have resistance here. Then VC equals 0. So this number one, VC equals 0. Since VC equals 0, the energy stored in the capacitor, which is WC, equals 0 also. What about IL? IL is a current in this short circuit, which is the current in the 2 ohm. Then you have to solve it using, you can use nodal analysis, or you can use current divider to find IL. IL in this case is supposed to be, I believe it should be 2 ampere. 2 ampere. Because this 3 ampere will be divided between 2 and 4. So most probably this is 2 ampere. Okay. And the current in the 4 ohm will be 1 ampere. But you can calculate it. This was just using a current divider. But if you use a nodal analysis, you can do that. And you can find the current. IL will be 2 ampere, for example. And then in this case, WL will be 1/2 IL square time, or L time IL square. L is the inductance. The inductance is 0.5 Henry. So this is L. Okay, so 1/2 L, which is 0.5, time IL, which is 2 square. This will be the energy stored in the inductor. So I hope that you do not have any problem in this one. And if you have any issue, just give me ask me in the live lecture, or you can email me. Thank you very much for watching this video, and see you in the next one.